What is good, guys? Welcome back to the channel. In today's video we're doing a EICR on a flat. So I am a commercial spark, so we're a commercial firm, industrial commercial, but we do also do domestic for friends and family. This is a friend of the company's flat, so we're just going to carry out an EICR on it, get it all tested up. With the new legislation, it's well overdue now, so yeah, we'll do that. I'm going to show you the process of an EICR. I've got a brand new KT63 Plus as well from Kewtech, so I'm going to show you all of that, as well as a few other goodies they sent me, and yeah, just show you how we EICR at Burgess Electrical. So first things first, the Kewtech KT63 Plus. So I did buy this on my Instagram. I got sent this months ago now to do like a review on it, a breakdown and stuff like that. And then Kewtech later approached me and said, do I want it for £500, which is an amazing deal. Obviously I'd already had it, unboxed it anyway. Then it got sent to the guys at Epic Veto. And then it's been sent back to me, so for £500, but they also chucked in a few goodies. So got a Kewtech face mask, that's going to definitely come in handy. A couple of Christmas Kewtech car smellies, and then this is the good stuff. So a Q2200 clamp meter. So yeah, it's just your standard clamp meter. It comes with probes as well, so it's good for like earth leakage and stuff like that. We'll do a bit of earth leakage testing with it today. And yeah, just a nice little clamp meter. Then we've got the single pole hazardous voltage and phase finder. So this, I believe, is like a serious volt pen. I'm not sure if it glows. I think you have to literally touch the metal. I'm not too sure. I did have a little look at it last night, but yeah, I'll have to give it a go and find out exactly how it works. But it looks interesting and it's really safe, so it will definitely come in handy industrially as well and commercially. But yeah, and then we have the KT63 Plus. So I did do a video on this. Now that I'm taking sort of video creation and the content a lot more seriously, I'm going to redo a video on it, just because yeah, the other one was made for Instagram, music was really loud, the video quality was poor, and yeah, so I'm going to redo one, but for now you just see me messing around with this today. So in the soft carry case you get the tester, and then in this bag here you have all your probes and what have you. So yeah, I really like the probes and all the accessories of this stuff. So I'm going to get as well strap, instruction manual. I'm going to get as well all the light bulb attachments and stuff like that. Kewtech do a really nice range of accessories. Just makes testing like really easy. So they've got like lamp holders that you can put your probes into, sockets that you can put your probes into. So obviously when you're doing like you can do a continuity test, but do it between neutral and earth and stuff like that, and change that around just by changing the probes around, so that's cool. But yeah, loads of little accessories, so I'm going to get all of them as well. At the minute, in my MB freebie, I've got my fluke. So this is going to go to, I think, either my brother, who also works for this company, who's going to learn how to test, or it could get shared around the apprentices, but this will go in there. My tools are all over the place at the minute, split between all the bags, so I'm probably also going to do a MB freebie testing sort of loadout with all the tools you need to test, with this in here, all the accessories and stuff like that, for like the perfect testing rig. So keep an eye out for that. This bag and this tester is available from Loadout, as well as these tools and everything like that. I'll put all the links in the description. Loadout's my tool shop, so if you didn't know that, I've got a tool shop for electricians. So yeah, that will be in the description, make sure you check it out. So we do all of our testing, we try to do all of our testing on site on this little Surface, this is a Surface Go, but on like Surface Pros. Basically it saves the office a pain in the arse of having to type up the results, you know, a week later and they haven't been there and all that sort of stuff. And it just means, you know, you never miss something when you've got to fill it out completely on site. As when you're writing it out on paper, you might miss something, you might forget something, and then you're not on site, so yeah, you can't go back. So yeah, log in, dongle should be firing up. Get a bit of light in here. The old Bez van there, look. In all its glory. This is just loading, sorting its life out. In the meantime, while it is, got a screwdriver. We'll get the cover off of this. Right, so all seems pretty sweet. And look, I haven't even got to test it because someone's wrote all the results down for me already. Look, we'll compare against these. That'll be good. That'll be sadly interesting to see. Don't look too bad, to be honest. It's all on RCDs. I mean, the worst connections are the ones made by the Wilex boys. But yeah, apart from that, it all looks pretty sweet. They're both working in principle, so yeah, we'll once internet's on, we'll start doing the tick sheets, filling the form out, all the boring stuff, and then we'll start testing. Right, so internet's finally sorted its life out. Get the old charger out as well, because I'm running low. I've definitely picked the worst place, because I'm paranoidly wanting to be able to watch the van while I write this out, but it's not a bad air or anything. I'm just paranoid about the van. There's a socket there. Can I move that out? Or shall I just do this? Just go in here. So we use the NIC online certificate system. I know a lot of people don't rate it, but you know, when you use it a lot, you do get used to it in its quirky ways, and you know, it ain't too bad. And when they update it with a bit of meaning, and it is always getting better. But yeah, I appreciate there is better systems out there, but for our company, it's just handy to all be on the NIC and all use that basically. Yeah, like we all have our individual logins. We can, you know, we've got QSs that sort of scan through, verify and stuff like that. So, you know, it just works for our company structure as well as you know, I can just bring this tablet out, and as long as you've got internet, you can jump on it. But yeah, the NIC get a lot of they get a lot of flack, and I think it's just people like to direct their frustration at the industry at them, to be honest. But yeah, I don't think they're bad, and I think they get a bad rap most of the time. But yeah, that's just me. Alright, so I'm going to time lapse my way through all the boring stuff, because no one wants to see that, and then we'll get testing. So how easy is this? Look, you know how bad flats are, like finding the mains and trying to get in there. Mains is there, board is there. Right, so this is the supply, the incomer. So it's a TNCS system. You've got a sticker there, but also you see you've got a live and a neutral coming in. So it's combined there and then separated at the head into a neutral and an earth. It's all looking pretty sweet. This has obviously been revamped when the smart meter went in, because that's a new head for that really old cable. I think these flats have been redone with all the new wiring. You can see all the old singles in tubes have been cut out and stuff like that. So it's obviously had a rewire, and it's to a good standard, to be honest. But yeah, the only thing is you've got a 16mm earth going up to the board, but off the MET to the head you've got what looks like a 10mm. So ideally that wants upgraded. Might be able to gain some slack on this, gain some slack on that, and then just replace that link, but that will involve cutting these seals, and I don't ever want to get into that. I might just put a note on the certificate. As long as the results are fine, and the impedance is fine, the external impedance, then you know, what can you do? We'll see. So it's got a 100 amp BS88 type 2B fuse in there. By all accounts anyway. Obviously I'm not going to cut the seals and pull it out, but you'd like to assume so, and the 25mm tails point that way anyway. That's pretty much it. We'll get a test result in a minute, and then we'll write all this down. Right, so I'm at the board. I've got my main earth disconnected. I only really do this on domestics when I know what's going on. Commercially, industrially, do not disconnect any earths. You don't know what's going through them. But yeah, that is disconnected. I've got all of these off, including the main switch. I'm just going to take an earth fault loop impedance test now to get the external ZE, and then we'll do a PFC as well. So there you go, 0.144. The other four's irrelevant really. It's nice to have that extra point, that extra resolution, but it's not really necessary. So yeah, 0.14, and then we tap this. There you go, 1.6 Ka. So if you didn't know, PFC is generally you know, your voltage divided by your fault loop impedance value. So 230 divided by 0.14 will come in at around, you know, 1.6 Ka. So yeah, obviously these are a little bit more accurate. They obviously do a little bit more than that, but generally as a rule of thumb, you can check your results, and you know, if you want to calculate it, or if you forget to take it, then you can just calculate it from your loop value. Obviously if it's 3 phase, you're still going to divide your fault loop impedance for that phase by 230, but then you're going to double that to account for the phase-to-phase fault current. So I'm just running through the supply characteristics page now. It's a TNS system, it's 1 phase 2 wire, and we confirmed the supply polarity when we carried out those tests, as well as visually. It's 230 volts, 50 hertz is the frequency, 1.6 Ka and 0.14 on the external loop impedance. The supply protective device is a BS88 general, just your standard BS88 type 2 fuse, rated at 100 amps. If this was not a domestic one, I believe you used to have to put it in, but maybe if it's not connected to the supply, you'd have to put it in, but directly to the incoming supply. But yeah, the short circuit capacity for a BS88 at 230 volts is like 80 Ka, I think, and then it's 50 Ka at 415. So yeah, it's pretty high. I think a 1361, sorry, is 33 Ka. But yeah, just if you didn't know, a lot of people don't know that one, so it is in the on-site guide somewhere. But yeah, 80 Ka, and yeah, make sure you check as well, because BS88s are used domestically, can and are used. A lot of people just assume it's your standard 1361 type 2B, which they always are, but yeah, a lot of the time as well, they're BS88s when you look closely. So yeah. So now we're on to the earthing page. So the earthing conductor is copper, and at its worst is 10mm squared, and the main protective bonding conductors are 10mm as well. I should think that it was probably never changed from 10mm, because the meter guys never did, because you wouldn't go to the effort of putting 16mm in just to leave it 10 there. But the other electrician obviously didn't want to cut the seals and all that, and I'm not going to get involved with it either, to be fair. I will put a note on the certificate, speak to the client, see what they want to do. But yeah, water and gas, I know they're visually confirmed. I will get the one to lead out and test them, make sure they're below 0.05. The main switch or switch fuse circuit breaker RCD, so this is a 60947 isolator. Its location is in dB1. It's 2 poles. Its rating and setting of device is always NA unless it has the ability to be set. So yeah, if you are, it will be rated at 400, but we'll just say 230 because it's not going to exceed that anyway. yeah, the rating and setting, people get this wrong as well. It's more, that's for like MCCBs or ACBs, where you can set the threshold, the current rating of it. So, you know, a 1600 amp ACB can actually be downrated to 800 amps, you know, or 1200 amps or whatever. So, you know, that's what that's for. It's not got anything to do with, like, you know, normal MCBs. It's more when you can set the characteristics of the circuit breaker. But yeah. Right, so tick sheets. I'm not going to go through all of these on camera just because it is super boring. I am going to do a video at some point explaining it, but this video is not the time or place. So yeah, I'm just going to crash through these, run off and check what I need to check, and then yeah, we'll get testing after that. Right, so I'm just going to show you how sweet this tester is when it comes to testing RCDs. So I've got it set on the auto function. I normally do it manually, just because some of the tests aren't necessary, but I just want to show you this. So I've got it set to type A RCDs because you ain't going to have anything else in the place that's sold, and then everything else is sort of preset. Just put the earth and the neutral clamps on, and then I'll test and I'll show you. All the RCD results on one screen. How wicked's that? Such a smart way of doing it. So then you can just come back and just write down the highest result. So this is the Kewtech single pole hazardous voltage and phase indicator. So you just hold down the button there, and then it's basically like a super duper volt pen. The only difference is you do actually have to make contact with a live part. So it's used for like situations where enclosures might be live and stuff like that. So if you were going into an LV cage or something like that, or messing around with earth bars in a switch room or something where you want to know if something's dead, this will tell you basically. So you should still prove it on a known source or on a proven unit, but I'll just show you it now in practice on this main switch. So as you can see there, it lights up and gives it a bit of lemon when it's live. If you go on something like this, nothing, you see. It still flashes to indicate it's working correctly. But yeah, on some stuff it does sometimes pick up and then like go like that, but then go off straight away. There you go, like on a neutral. So it does, but yeah, you know it's dead. So, but it's good for stuff like that. It's good for, like, you know, touching enclosures, or, you know, if a lamp's not working, you can just put it in and it'll give you a bit of indication. Again, you know, it's not going to be used for safe isolation, but it's a good indicator. It's good for fault finding, investigation sort of work, and yeah, just working safely. When you're working in industrial environments, just having this in your pocket, touching everything, you know, before you touch it is great. So, and it's just easy to use with gauntlets on and stuff like that too. It's really big and, you know, clunky, so that's what you want. But yeah, it's pretty cool. So this is just like a mock-up of, this is the circuit builder on the NIC, where you can just enter like all sorts. But what I do is I'm creating all 8 circuits, and then I'm just putting in like any stuff that's going to be the same. Like most of them aren't rings, so I've NA'd all of them, and I'll just change them for the rings. I'm not doing any R2 testing, so I've NA'd that. I've insulation resistant tested the board at 250 on all the circuits that could be. I don't limit and I don't not do it, but I don't go through linking all the dimmers out, taking all the lamps out, and sort of linking everything through, just because it's unrealistic. You know, it's a relatively new property. Everything looks visually okay, everything's tested out fine. You know, it's at the inspector's discretion. If I went to an older property and the wiring was a bit iffy, I would go to the effort, you know, but ultimately I'm putting my name on the certificate and I'm happy with the wiring to the point where I don't need to charge the customer more money to spend more time here IRing every single leg of cable when it's, you know, it's fine. And all the armchair experts will sit there and say, yeah, you should do it, but you've got to be realistic. But yeah, the RCD operating time, I'm putting down 30 milliseconds. I tested the other one and 30 milliseconds was the highest of both the RCDs. You know, you're not going to fill out the RCD as if it was a circuit, because it's not true. So yeah, I just put the highest of all the RCDs for all the circuits, just because at worst, that's, you know, that's when it's going to trip. The test buttons work, so again, you can tick all of them. You can tick polarity for them all, because obviously you'll confirm that. Short circuit capacity and the breaker types are all the same. Current rating, cable size, number of points served, description is all, and the results are all variables, so you leave them blank. But yeah, it's just a quick way of, look, if I press this, it'll create, there you go, 8 circuits like that. So yeah. Right, so first circuit is cooker. Next circuit is power flat.
A few moments later.
Sweet. So safe to say there's only one cooker. Heating. Let's just go have a look at that. So, put it in here. Yeah, so heating is here on a plug top. Lovely. There's also, I guess, a socket for the immersion if needed, but then you'd have to unplug the heating, so that's not ideal. I'll probably note that. Maybe there was a socket there, but yeah, probably don't need to use an immersion in a place like this anyway, but it's not that big. And then there's I'm guessing a pump for the shower, which must go up to the loft. So the heating is 2 points really, isn't it? Yeah, in an ideal world you'd feed that off of here, and that would be shower and heating, because there's a 3 amp fuse, but they've nicked it for the shower and then put that on the plug top, so whatever. And that is just lashed as well, which isn't ideal. That is for the thermostat. So 2 points on the heating. Smoke alarms, there's one there, none here, none there, none there, none there. There's probably a heat in the kitchen, one at the top of the stairs, there's none in here. Oh, little cupboard. And then, I'd be surprised if there's not one down there. That's jokes. Double socket, maybe this is that socket. Gas bombs. So yeah, 3 smokes on the circuit. Obviously, this is just from what I can see. When it gets tested, it will all become apparent. Right, first circuit that is up is the cooker. So I'm going to kill that, kill the RCD just to be safe. I'm going to get the earth for the cooker, which... where the hell's that? We've done it back to front potentially, yeah. So yeah. Just going to grab my long nose pliers. So grab the earth cooker. And can't gain enough length in it, so ideally I'll I'll just dot it into the breaker. So the live is not long enough, the earth is not long enough to get into the breaker without sort of taking the board apart, so I'm just going to hold them together with a crop clip. And then I'll take you into here. Right, so I've got it set onto continuity. I'm going to plug into the cooker socket, which is handy that it's there actually, and then I'm going to press test 0.42. So yeah, shorted them out, tested them at this end 0.42, and then I'll add on that 0.14, which will make it 0.56. So let's go see how right this person was. What do they get? Cooker 0.46. So they must be the dead values, I would say. Maybe they tested at the cooker outlet, and that gave them that extra 0.4, and that is the dead measurement. But yeah, 0.42 is close enough for me, so I'm just going to go note that down. Right, so cooker R1, R2 is 0.42, and then if we add on our external fault loop impedance, that's going to be 5256, 0.56. Cool. Next is the power in the flat. So this is a ring. Yeah, it's a ring. So I'm just going to get rid of these. We'll do our end to ends. We'll do our ring R1, R2, and then we'll add it together. This cooker circuit back together, and then we'll test the ring. Oh, they haven't, have they? Yeah. So I'm going to test at one of the sockets, because you see there's doubled up both the earths in this, and it goes all the way around there into the back. It's just going to be a nightmare splitting it. It'd be much easier to do it at a socket, so make sure that that's off, that's off. Turn that all off anyway. And then we will go to one of the power in the flats and test it there. Nice central point, say here, and then right, so I've split the ring, and then I'm just going to put one crock on that, one crock on that. Press test. 6.9, cool. So you'd expect the neutrals to be the same or thereabouts. 0.68, yeah, so pretty much bang on. And then the earth should be, well, it should be 1.67 times the lives, but we shall see. 1.38, so yeah, not far off. A little bit higher, maybe some back boxes playing with that figure a bit, but yeah. So I'm going to go write these down, and then we'll do a R1, R2 figure of 8 test. Right, so I've got one cable's live going with the other cable's earth, and then I've got the other two out, so I'm just going to clip onto them, press test. So 2 ohms. So I'm going to divide that by 4, which is going to be 0.51. So that is our example reading. So now when we run around and plug into all the other sockets on this ring, we'd expect them to be within 0.05 of 0.51. So yeah, we took an example reading here. I'm then going to link these out with another Wago to make that figure of 8, like so. Try to do it with one hand. There you go. And then yeah, run around all the sockets, and it should be within 0.05 of 0.51. Right, so all the armchair experts will tell me off for this, but with by fluke there's like a bit of metal that you can use to null these, but not all testers come with that. So what I do, especially commercially, like with a floor tile or something, in this case there's a nice that valve has got a nice casing which will do a good job. I'm just going to tap everything on it and press the null button, and that will null the leads for me, so like this. There you go, so that's just nulled that. Yeah, 0.12. And then, like I said, I've got that in figure of 8, so I'm just going to run around all of the sockets now. 0.55. 0.48, 0.54, 0.51, 0.56, 0.48, 0.50, 0.50. So yeah, everything's within 0.05 of our example reading, which was 0.51. So that ring is sweet. Obviously we'll note down the highest, and then yeah, I'll put this back together. We'll move on to the next circuit. I'm not going to show you another ring just because it's more of the same. The video just gets longer and stuff. I'll show you testing a couple of radials now and doing some visual inspections. So I like to do like 20% visual on somewhere like this where it's in good keeping, it's done to a good standard, and then if we find anything bad, we'll extend that net to 40%, 60%, and then ultimately 100% if it's, you know, really, really bad. So, but at the minute, you know, what I have seen is good. I'm not really being pushed to want to see any more, but obviously I will make sure I inspect 20% of each circuit, 20, 30%, you know, it's always more than that anyway by the time you start testing and taking stuff apart. But yeah, and then hopefully we don't find anything bad. So I've talked this up a bit. It does, it will measure earth leakage, but it will only go down to 0.0 of an amp. So yeah, it will only, the lowest amount it will pick up is 10 milliamps. So still good, you know, but not finite like a dedicated earth leakage clamp meter. But then the benefit of this one is it does go up to 1000 amps. But I'll just show you at the minute what the live's pulling. So we'll get the rest of the board on. We're pulling, it's not even an amp, would you believe it? But again, nothing's running in here. And then if you wanted to measure the earth leakage, then you'd clamp it around both of these, and it's saying nothing. So that's good. Oh, there you go. It's going up to 3, but I think that might be something coming in, because if it wasn't, I suppose you got 2 RCDs, you'd think if it was 30 milliamps it'd be tripping these RCDs. Yeah, it's gone up to 6 now, so that might be coming in from the supply end. But yeah, right, so next is the lighting circuit in the flat. It's the only circuit on, just so I can ascertain what is what. So you've got one there, one down there, 2, 3, I'm not sure about that one. Not sure about that one. Nope. 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 So maybe this one as well, just because that has got the same, that switch is sharing the feed, so I'll just use this as well. So if that's on, should get something in there. And we aren't, it might be easier to just go up here, to be fair. So yeah, nothing on the switch line. The only other one I wasn't sure about, because it would probably be on it, is this one, but maybe the lamp's gone. Get that off. There you go. Shove this in there. No, nothing. So it is just kitchen lights, that light, and the one downstairs. So that is probably wrong, to be fair, because the other circuit is down on the board as kitchen lights, but I would say this is kitchen. Kitchen. I cannot type. Kitchen / hall. LTG. So 1, 2, 3, 4 points served, and we will we'll short them out here, and then we'll go to the furthest point, what we think is the first point, which will probably be the kitchen, and we'll test from there. So now I want to grab the lighting circuit, 1, 2, 3. 4. Okay, it should be, yeah, it should be this one. So we'll get that out of there. Is it long enough? Yeah, it is. So make sure you're off now. Get you straightened out. And then we'll just put it in here. Cool, so that's sorted out this end. We'll go to what I think is the furthest point. Right, so the furthest point I would say by the time you get to that switch, which probably goes up to there, I would say this is the furthest point. So I'm just going to unscrew this here. Saying that, I'm way off. The furthest point is definitely down here. So hopefully I can still reach it without steps. No pressure. So that's somewhere safe. Let's take you out, bayonet. So this is where those Kewtech like bayonet adapters and stuff that I was on about really come in handy, because you wouldn't have to do any of this, which isn't ideal. It's not ideal, it's just taking the place apart and plugged in and got a result. So that is lovely. Look, that's just an old Beezer box. Earth not connected, rusty. Bit of an old cable as well. So, yeah, it's not ideal, no grommet either. I think they've used the conduit system. When they rewired the place, they've done a great effort of rechasing, redoing everything upstairs, but this, I bet this was a nightmare to get down. So I suspect, I'll inspect this as well. That would be an existing conduit and stuff. They've done something here. And they've come through the wall, which will probably be a tube system to get to here. They've drilled through the back into that or something. I'll have to unscrew that and take a look. But anyway, we'll test here and then we'll move on. .78 is quite high, but not high for a lighting circuit, to be honest, actually. Especially by the time it gets down here, goes in the switch. I am going to see if I can get that earth on that box at all, but it's not looking likely. Yeah. Right, so that's back together. I managed to get the earth. I changed them for brass M4s, and then put an eye crimp on it and screwed through. So yeah. Next up is the kitchen ring. So I'm not going to bore you with that. I'll just do a similar, exactly the same test as last time, to be fair. 1.78 and then plus B 1.88, 1.92, 1.92. Cool. Yeah, next up's the power in the kitchen, so I'm going to run around and test that. I'll do the heating with you and I'll do the smoke alarms with you, and that'll be it. Right, so that is the heating circuit linked out. I can now, I believe it's got a plug top on it, so I can just get away with using this thing. So we shall do that. Plug in. So, come on. There you go. Just going to null the lead again. Don't judge. There we go. Unplug that. Plug this in. There you go, 0.22, nice and low. So I'm going to go jot that down, calculate the ZS for that, and then I've got the lighting circuit for the rest of the flat and the smoke. So I'm going to skip the lighting circuit for you guys, and then I'll do the smokes. Right, so I've got the earth in with the smoke circuit there again. So I'm just going to go to the furthest point, which it's got to be this one, to be honest, isn't it? I'll just grab a terminal, actually, small terminal. This one will do. And then these have a release in them there, so like so. That's them coming down. Test the battery while we're here. Some people note it, some people don't. Battery's dead. So I will note that on the certificate. It's not really our bag. Our regs don't really cover it, but do you know what I mean? I will say, just because it helps me sleep at night, basically. Just get this off, and there you go, that is the connections there. Put that on one little shelf. And then, if I'm shorted out correctly, we should get a reading here. 0.43, so yeah, it's probably about right. It's not that long, but it's 1.5, so yeah, I'll jot that down. Right, so I've got the long lead out. I'm just going to not null it because it doesn't seem to null out right, but I will just measure the resistance of it. Remember, it's that we can minus it from the final result. Go on there. There you go, 0.99. So now I'm going to run this down to gas. Try get a good, yeah, get some good copper showing there. Right, and then run back up and try and do this whilst holding everything. 1 minute. As you can see, it's 0.01, which is well within and what we want to see. We'll just do the same with the water now. Right, so the water was exactly the same, which is sweet. So yeah, I'm going to get this packed away and then we'll do some visual checks, final walkthrough, and then we'll get out of here. Right, so I'm just going to do some functional checks of everything as well, just to prove that these trip. Yeah, so the RCDs are both tripping, MCBs are all operating correctly, main switch is operating correctly, sweet. So I'll label this up in a bit after I just do some final visuals, 20% of each room, just unscrew a few bits here and there. Right, that is us all done for the day. So board cover is back on, everything's screwed back, everything's back on, functionally working and sweet. Yeah, it was satisfactory. Couple of C3s, plastic DB, no SPD, no sleeving on like the neutrals or switch lines, and just, you know, normal stuff. Also noted the earthing and the lack of batteries, or the failed batteries and the smoke alarms. Not really our sort of area, but I just like to note it down anyway. But yeah, apart from that, you know, it was pretty sweet. Had a good look at everything, and it's done to a good standard and it's compliant. I just wanted to say, firstly, you know, commercial electrician, so don't think, you know, there will be the odd domestic video like this, but yeah, primarily we're commercial, so don't worry about that. But also, you know, this is a 20-minute, 30-minute video, but that is in no way a representation of the testing that was done today and the inspecting that was done today. So we've been here best part of the day, 6 hours. I've been here best part of the day, 6 hours, and you know, you're seeing a 20-30 minute video, but I'm not going to show you all the boring bits, the me unscrewing stuff, the me scratching my head, trying to look for stuff, work stuff out, and do you know what I mean, crawling through cupboards and stuff like that. I've tried to show you the interesting stuff, I've tried to show you the new tester as well as much as I can. But yeah, I just wanted to say, you know, don't think this was tested in sort of half hour, an hour, and yeah, you know, it's been filmed in a very conservative way. But yeah, if you're enjoying the videos and you want to show your support, please like, subscribe and hit that bell button. It also means you'll never miss a video. And yeah, as always, thanks for watching guys, and I'll catch you on the next one.